GHG emissions from Australian road transport. The report focuses on the current GHG emissions performance of the Australian on-road fleet and the main factors that contribute to an unexpected increase rather than a decrease in these national emissions. Dr. Robin Smith's talk will then discuss the case for rapid electrification of the Australian fleet, the delays due to fleet turnover, and the expected impacts on emissions in different scenarios, fossil fueled versus more renewables in the electricity sector. Please welcome Dr. Robin Smith, the Director, Transport, Energy and Emission Research.
Thanks, John. Can you see my presentation? Okay, thanks. So I'm going to talk about a number of recent research items into electric vehicles. Very quickly going through the problem here, Tim Flannery already pointed it out, as well as many other presenters. All Australian and New Zealand jurisdictions have set net zero greenhouse gas emission targets by 2045, 2050. But as Tim Flannery already pointed out, we need much faster action than that. In fact, the Paris Agreement suggests a 50% emission reduction worldwide by 2030. About more than 20% of total greenhouse gas emissions come from transport, which is itself dominated by road transport. As Mike already pointed out, total CO2 emissions from Australian road transport have increased by 31% in the period 2000 to 2017. When you look at this plot here, this is the fleet average CO2 emission rates by year of manufacture for new vehicles, for passenger vehicles. The official figures basically suggest a gentle slope downwards. However, if you look at the real world emissions, what actually happens on the road, there is definitely a different picture. Especially around 2015, we've seen a trend reversal, which basically means that the on-road average emission rate is increasing with a few percent each year. And the culprits for that are basically the continuous increase in vehicle weights and a shift to four-wheel drive vehicles, mainly diesels. You can also see that the gap between the official test results and the real world performance has increased from 10% to almost 35%. Transport emissions are increasing, and this was the emission rates, but also VKT is increasing as well. So it's basically accelerating in that way. So that's not the thing we want to see. Also, a comparison with international best practice confirms that Australian passenger vehicles are underperforming in relation to CO2 emissions and therefore fuel economy. So what to do? Do electric vehicles help? Well, definitely there's potential. As we all know, Australia uses a lot of fossil fuels, more than their peers around the world, despite the huge potential for renewables. And we could definitely have, lots of renewable energy feeding electric vehicles. So there's the potential. However, it's actually a very complex question. Are electric vehicles better than fossil fueled? The answer depends really on local conditions and time, and there's lots of dynamic changes at a very complex level that need to be accounted for. So one tool to do that is called a life cycle assessment, which is a holistic and systematic approach that looks at all the aspects of vehicle's life and its associated impacts. It's also called cradle to grave. Interestingly, there's been a lot of LCA studies around the world, sometimes with conflicting outcomes, but most studies look at a deterministic approach, whereas only a few have deployed a probabilistic approach, which actually explicitly accounts for uncertainty in the inputs. And that's what I've done as well. So a probabilistic approach basically is very useful because it determines the robustness of the outcomes. And you can also use it to look at which aspects are most uncertain and warrant further examination. So what I've done is looking at two emission factor models. So electric vehicles versus fossil fueled. The functional unit is grams of greenhouse gas emission per kilometer. Looked at vehicle production, fossil fuel production for fossil fuel vehicles, electricity production, vehicle operation, and disposal and recycling. So the LCA considers the most likely and plausible values for each aspect and also quantifies the uncertainty in that. The plausible range is either quantified with statistical techniques or estimated from the literature. and I've used Australian and international data sets as much as possible. The uncertainty is parameterized with probability distributions, and a Monte Carlo simulation is used to propagate the uncertainty reflected in those inputs. A bit more detail. So I've used, for example, Copilot Australia, which is a vehicle emission software specifically developed for Australia, modeling the emissions of 226 vehicle classes for 3 greenhouse gas emissions. The Australian fleet model predicts dynamic changes in the on-road vehicle population for 1,240 vehicle classes for each base year. There are detailed vehicle parameter data sets, both Australian and international databases. So we have the Greenhouse Vehicle Guide, the VFACTS, other databases like the TER database that I've developed. And then, of course, analysis of Australian greenhouse gas emission data, energy data, and fuel statistics. Again, there's quite a lot of data you can actually use. National greenhouse accounts, Australian energy statistics, and clean energy regulator data. Then there are meta-analysis studies. They're quite relevant because they review a lot of international studies, and I've requested and received underlying databases from selected authors, for example, in terms of infrastructure, greenhouse gas emission impacts. And of course, a whole range of international scientific papers and reports, looking at including a detailed analysis of underlying data, for example, into grid transmission losses, battery charging losses, and on-road electricity use of electric vehicles. Now, the main thing was to quantify the plausible value, but also the range in values reported. And what you get is basically a distribution of plausible values and uncertainties. Now, this is propagated through Monte Carlo simulation, which I mentioned before, and jumping straight to the conclusions here. So accounting for the variability in greenhouse gas emission factors, looking at all relevant life cycle aspects, the conclusion is that electric passenger vehicles are expected to significantly reduce the average life cycle greenhouse gas emission rates for passenger vehicles in Australia with 95% confidence. In fact, of all those simulations, there was no single outcome where fossil fuel vehicles had better emission performance than electric vehicles. The weight of evidence suggests that electric vehicles reduce greenhouse gas emission rates with about 30% on average, but it could range between 16 and 40%. And that's for the current Australian electricity mix, which is largely fossil fuel based. I looked at 2 more scenarios. First one is a worst case marginal electricity scenario. This is relevant for short-term impacts to assess the case where new electricity generation coming online is actually fossil fuel based. And I've assumed a mix of coal, gas, and oil here. I also looked at a more positive renewable energy scenario where there's a mix of fossil fuels and renewable energy. So for those specific scenarios, the greenhouse gas emission rates will still be reduced with 100% fossil fuels between 5 and 30%, about 15% on average for 100% fossil fuels, but definitely will be able to provide deep reductions in greenhouse gas emission rates in the order of 60 to 80% for a more renewable Australian electricity mix. And this is for the whole life cycle. It's not only for operational emissions. So in conclusion, the rapid electrification of the Australian PV fleet, which Jonathan talked about, seems to be a robust way to reduce our greenhouse gas emissions from road transport. It will immediately provide already significant reductions, even with our current electricity mix. And of course, those emissions will continue to drop further as Australia's electricity system is increasingly decarbonized. And we better get started. So this is the total sales of new vehicles, passenger vehicles in Australia. It's represented by the area, the blue area, and you can see what the BEV sales are doing in 2018, a very small dot. And when compared to large fossil fueled vehicles with high emission rates, we definitely need to get into it because those vehicles remain in the fleet for quite some time. I've got a little bit of time left, and I just wanted to touch on another item I think that's important for electric vehicles, which is air pollution. Now, of course, the electric vehicles don't have an exhaust, but there are air pollutants that all vehicles produce, which are called non-exhaust particles. And they basically are released due to brake wear, tire and road wear, and resuspended road dust. And there seems to be an emerging view that electric vehicles actually will not help with this and even increase emissions compared to the current on-road fleet. So I was quite interested to look into that in detail and see if that actually holds through, because it can be used as an argument against electric vehicles. So the study is published, it looked at all the arguments, it reviewed the assumptions, and again, conducted a probabilistic analysis there. So basically what I've done is create a database of published emission factors, do a statistical analysis, and just jumping to the outcomes there. The weight of evidence suggests that electric vehicles reduce particles, non-exhaust particles, with 1 to 46%, with 13% on average. So the conclusion really is that the negative focus on electric vehicles is not justified in this case, and should rather focus on the heavier diesel cars and SUVs that are being on sale at the moment, especially given the growth in diesel sales over the last few years. Those reports are all available and downloadable on the websites, and that's it. Thank you very much.
Thank you, Dr. Smith. That was fantastic. It's amazing. I've discovered that the World Health Authority declared diesel a carcinogen in 2002, and yet here we are seeing graphs that usage is going up. I'm sure there's a court case there for someone, and it won't be the three of us.